Hey guys, can you hear me?
Yes, sir.
Okay, so should we get started or should we wait for 2 more minutes? We have 10 people joined. We'll give another 2 minutes for rest of the people to join. Okay, so I think we can get started. Let me share my screen. Let me know if you can see my screen. You guys can see my screen?
Yes, sir.
Okay, so let's start. Okay, let's do a quick recap. Okay, so since because we had a break in between, not a break. Yesterday we didn't had a class as per the plan. So just wanted to quickly do a recap and then we move on to the new topic. So what did we saw so far? So in the first class we talked about cloud introduction, where we try to understand about what is cloud and what's the primary use case of cloud and how cloud differs from on-premise infrastructures and what are the benefits we get out of cloud by using cloud, what are the benefits we are getting. So we just went to all these things and we saw how to create AWS account and what are the prerequisites you need to have to create an AWS account. And then we also talked about what is regions and what is availability zone and what are the certifications you can focus on if in case you are looking to get certified. Right, so these are the things which we saw. In the next class, we talked about IAM. What is IAM service means and how it can help you to manage the console access, right? So who can log in into your AWS account and what they can do into your account and what they are allowed to do and what they are not allowed to do. Everything can be controlled with help of IAM. And there are a couple of components in IAM which we looked upon. We talked about IAM user, we talked about IAM group, we talked about IAM role, we talked about IAM policy, and then we also talked about AWS CLI, how to use AWS CLI to interact with your cloud platform, and how to create access key and secret key, and how to install AWS CLI and use the access key and secret key to interact with your cloud account. Right, all the hands-on examples, whatever we saw, it is available here. Creating user, creating group, and attaching policy to the user and group, and creating a role, and attaching a policy to it, and also how to install AWS CLI. And after installing AWS CLI, how you can you can use your access key and secret key to interact with your cloud account. Right, so that's about IAM. And the other day we started with networking, where we talked about VPC, what is VPC, what is subnetting, and we talked uh, from a layman perspective, right? So how you like we took an example of like a apartment. In that like VPC is more like an isolated environment where your workloads can be hosted, where others cannot interact with your workloads, right? So and also you what is subnets, how subnets can be segregated under VPC, and what is public subnet, what is private subnet, how you can connect it with the real-time example. So we just went through all these things, and we talked about internet gateway. What's the use case of internet gateway? And we also talked about NAT gateway. So what's the use case of NAT gateway? So whereas NAT gateway is predominantly attached to private subnets, whereas internet gateways are predominantly attached to public subnet, right? So we saw theoretically about this VPC subnet, etc. So today we are going to see how to create this thing in the console. So it's going to be more on hands-on, and if you just open this hands-on, expand this hands-on folder, so you'll be able to see how to create all these things explained here. When it goes to VPC, step by step, I have given you like how you can create VPC, right? So you can follow this. If you want to create a subnet, so you can just follow this. And if you want to create internet gateway, you can do this, NAT and route table. So for everything, the steps are given here. So now we are going to go ahead to the console, and I'm going to do it. So later when you try by yourself to create all these things, you can follow this document, and also you can watch my recordings. Okay, so any questions on the previous classes so far before we move on to the hands-on?
Sir, as five VPCs can be created in a single region, is there
Right?
any limitation? Is there any limitation for subnets? That how much subnets we can create in a single VPC or a region?
Okay, good question. So there is no limitation as such in terms of subnet creations. Probably I'll explain you in this way. Okay, so you're creating a VPC. Okay, now VPC is what? Okay, so it is a isolated layer you are creating to host your workloads. Okay, when you create a VPC, you need to size this VPC. Okay, so what I mean by sizing is I need to say how many IP address should be part of this VPC. For example, when I create a VPC, I'm saying that this VPC totally should have around 2000 IP address, which means that I can create 2000 virtual machines inside this VPC. Okay, which will be dedicated for my organization where others cannot interact with these machines because this VPC is an isolated layer. Now, these 2000 IP address is created, is part of this VPC, but you're not going to directly go and create a machines on the VPC. Instead, you need to create subnets. Now, subnets is about you are just splitting this 2000 IPs into small chunks, and you can do how much ever smaller you want. For example, you wanted to create one subnet with 500 IP address, another subnet with 500 IP address, another subnet with 500 IP address, and probably other two. One is 250, another one is 250. So now you have created how many subnets? One, two, three, four, five subnets. Okay, so you had 2000 IP address in your VPC. Out of that, you created five subnets. You splitted the same VPC IPs I mean, you just splitted your VPC into 5 different chunks, which is your subnets. So if you want to go more smaller in the micro level, you can do it. Like per subnet, you can create 250 IP address, which means that you can create 10 subnets. Okay, so how many subnets you can create? It depends on your VPC sizing, and you can go as much smaller you want. You like the least would be around 32 IP address, which means that a subnet can be smaller, like which will have only 32 IP address. Imagine if you are creating a subnet with 32 IP address. So in that case, you can create hundreds of subnets out of this VPC. Okay, so there is no any limitations as such in terms of subnet creation. It depends on your VPC sizing. Now, how are we going to decide the VPC sizing? We can decide based on the requirement what we are going to work on. So in the real time, so before you create this VPC, you will be aware of for what you're creating this VPC. For example, you're creating this VPC to host at around 2000 virtual machines. Currently, your organization is planning to create 10 virtual machines. When business expands, it might go to 200, it might go to 1000. So you need to understand the scale of your workload, and you need to size your VPC accordingly. Okay. So it is purely like it is our job to understand the requirement and create a VPC accordingly. So, and also when you create a VPC, you're not going to directly give the sizings like how many IP address you want. It is most predominantly done with help of CIDRs. Okay, so based on the CIDRs, the sizing will work. So if you ask me what is CIDRs, CIDRs are deciding how many IP address you're going to have as part of this particular VPC and subnet. Okay, I'll show you when I create that VPC. Okay, and other thing is when you create a subnet, you can create a subnet into different availability zones. What is availability zone? For example, here we have a region called North Virginia. So in North Virginia, you have uh, let's take a known example. We everybody know that there is a region called Mumbai, right? So let me sign in again. Okay, so over here, you can see we have a region called Mumbai. Okay, so Mumbai region ID is AP South 1, right? So this particular thing, whatever you are seeing, is called as region. Now, in every region, you will have multiple availability zones. For example, let's split Mumbai into three. Okay, so East Mumbai and South Mumbai and West Mumbai. So what AWS will do, they will have their data center in 3 different location in Mumbai. Probably one data center in East, another data center in West, and other data center in South. Okay, so why they are doing this? Because, for example, due to heavy rainfall, East Mumbai is uh, completely down. There is no electricity, there is no power supply, and there are a lot of issues going on in East Mumbai. Still, you will have other two data centers operational in the Mumbai region itself. This particular data centers are called as availability zones. Okay, so in the AWS terminology, they call it as availability zone. It is nothing but a data center. Okay, similarly, every region will have their own availability zone. Mumbai will have 3 availability zone. North Virginia, US East one will have up to, I think, 6 availability zones. They have 6 data centers across North Virginia, right? So now what we will be doing when we create a VPC, VPC is kind of a global component. Okay, VPC is always bounded to region. For example, here, when you create a VPC, this VPC is created in the Mumbai region. But when you create a subnet, this subnet will be bounded to availability zone. Like I'm creating subnet A, subnet B, and subnet C. Now, subnet A will be part of East Mumbai, subnet B will be part of South Mumbai, and subnet C will be part of West Mumbai. Now, when I create a machine, I will not be attaching a machine directly to VPC. I'll be creating the machines in subnet. My virtual machine 1 will be part of subnet A. My virtual machine 2 will be part of subnet B. My virtual machine 3 will be part of subnet C. So why I'm doing it again? Because if subnet A is down, subnet A is part of East availability zone, East data center. If subnet A is down, because of that, if the virtual machine is down, still other virtual machines will be running into different availability zone. Okay, so always subnets will be created into different availability zone, whereas VPC will be binded to a region specific. VPC is a region specific, subnets are availability zone specific. And when you create a virtual machine, you will eventually attach your virtual machine mostly to the subnets, not directly to the VPC. Did I answer your question?
Yes, sir. Sir, so it will automatically choose the availability zone, or we have to provide that.
Yeah, yeah. We need to mention that. I will show you when I'm creating it now. So I'm going to click on VPC here. When you create a VPC, when you click on VPC, when you click on VPC, you should see there is a default VPC available here. Okay. So in every region, without you creating a VPC, there will be a default VPC available. Okay. Don't get confused. So this is something which is created and kept it available for you by AWS itself. This particular VPC is called as a default VPC table. You guys lost me?
Yes, Vijay. In middle, we can't hear anything.
Can you hear me? Or
Yeah.
is it fine now?
No, we just still that.
Can you guys hear me? Is it fine now?
Yes, yes. Now it's fine.
Okay, it's here so that we can continue. I don't want you guys to lose what I'm talking about. Can you guys hear me? Is it fine? Shall we
Your
continue?
voice breaking, sir.
Breaking, huh? Okay. Okay, so I just changed my network. Just let me know if it is fine. I'm sharing my screen. So can you guys see my screen and can you guys hear me?
Yes, sir. Now it's clear.
All right. So what I was talking about is in every region, whenever you switch a region, you should be able to see a default VPC available here. Okay, so I am switching to multiple regions and you can see there will be already a VPC available. This VPC is called as default VPC, right? So AWS would have created a default VPC in every region for us. Okay, if you're not creating your own VPC, you can still host your workload into a default VPC. Let's take Mumbai as an example, since because we were talking about Mumbai. In Mumbai, you can see there is a default VPC. And if you go to subnets, you will see 3 subnets are available. 3 subnets are part of, if you scroll down here, you can see availability zone. One subnet is part of availability zone A, another one is part of C, another one is part of B. And what is the ID of Mumbai? Mumbai ID is AP South 1. And availability zone, you can see 1A, 1B, and 1C. Just that alphabet is added near to your region. So if you go to other region, for example, if you're going to Singapore, the region ID is AP Southeast 1, and availability zones will be AP Southeast 1A, AP Southeast 1B, and AP Southeast 1C. Are we clear so far? So now we are going to go ahead and create our own VPC. So this is a default VPC. Whenever you go to VPC section, don't get confused by seeing something there. So this is the default VPC, and this default VPC will be available in every region wherever you switch. Okay, so by default, AWS would have created a default VPC for our use case. Whether to use it or not, it is up to you. Okay, so you can still go ahead and create another 4 VPCs for your purpose, but there will be always a default VPC, and you can't delete this VPC also. So there will be an option to delete this VPC, but it is better not to do it. So generally in the real time, they will not do it. So yeah. So now let's go ahead and create a VPC. So whenever you try to create a VPC, there will be 2 options. One is VPC only or VPC and more. When you click on VPC only, you can create only the VPC. When you click on VPC and more, along with VPC creation, you can also create VPC and subnet, etc. If you click on VPC only, you can give your VPC name and what should be your CIDR and tenancy I'll talk about, and then you can click on create VPC. Okay, so just VPC will be created. If you want to create subnet, you need to go to the subnet console. If you want to go create internet gateway, you need to click on internet gateway. If you want to create NAT gateway, you need to click on NAT gateway. But what if I want to create everything in one single click? Then you need to click on VPC and more. And you can see AWS provides a nice graphical view here to understand the flow. Okay, so I'm going to give a VPC name here. For example, I'm going to give a name called okay, so let's take an example, book my show. Okay, so that's a VPC name. Okay, so now this is the place where you're going to define what is the size of your VPC. You can see here the least what you can start is 10.0.0.0/16, and you can get 65,000 IP address in this VPC. And remember one thing, the VPC IP address, whatever you're giving, it should always start with particular range. It should start with either 10 dot, or it should start with 172 dot, or it should start with 192 dot. These ranges are considered as private IP address range. You can give 11 dot, or you can give 100 dot. Okay, so that and all, it is not a right way to give. Any IP address range you are giving, it should start with either 10 dot or 172 dot or 192 dot. For example, instead of 10 here, I can give 172.0.0.0. This is acceptable. Or otherwise, I can say 192.0, 192.0.0.0. These are official private network ranges. Okay, so approved by internet. Okay, so I mean, in the internet world, these ranges are considered as a private IP address range. So let's go with the default whatever AWS provided, 10.0.0.0. And when you say /16, you can see how many IP address you will get in this VPC. You will get 65,000 IP address, which is massive, which means that you can create 65,000 virtual machines, and it is pretty big. And if you don't want this many IP address, you can increase the CIDR here. When you say 17, you can see the value changes here, which is 32,000. And when you say 18, you can see 16,000, 19, 8,000, 20, 4,000, 21, 2,000, 22,000, 23, 500, 24, 256, 25, 128, and 26, 64, 27, 32, 28, 16, 29, 8, 34 IP address, 31, 2, 32, 1 IP. Up to 32 you can go. Okay, that's the, so there is an octet calculation in that. So I don't want to get into this calculation, how these are calculated. If you want to really know about it, so you can just Google it, like a subnet CIDR calculation. So you will get more detail about like how the subnets are calculated, what is CIDR and what is CIDR notation and all these things. So just give me a second. Okay, so over here, if you go, you will be able to understand how the CIDRs are calculated. Okay, so it will give you a brief understanding about, so it is more like a core networking concept. Okay, so uh, so you will be able to see what are the CIDR ranges available here, and you can just see, for example, if I say 172.0.0.0/22, calculate, you will be able to see what would be your usable IP address. You can see here the usable IP address is 1, and this is how your calculation will look like. And when I increase it to 25, you can see the usable IP address is 128, and the IP address range starts from 172.0.0.0 to 127, which means that any virtual machine, whatever you are creating, the virtual machine IP address will start like this: 172.0.0.1, and it goes up to 126. Okay, so yeah, go through about it. Okay, so you'll be able to understand. For now, what we are going to do is we are going to create /20, which will be around 4,000 IP address. Okay, so now, and we are creating IPv4 IP address, not IPv6. Okay, so if in case you wanted to use IPv6, then you need to click on this Amazon provided IPv6, where you can create IPv6 IP address. Okay, but we are not going to do that. And tenancy, you can see there is a default and dedicated. So dedicated means your VPC will be hosted in the dedicated hardware, like dedicated switches and routers will be provided for your your VPC, but default means a shared VPC, which will be hosted into the shared router and switches. Default is fine for us. Okay, so dedicated will cost you more, but yeah, so that is default is absolutely fine. And here you need to define how many availability zones your subnet should be splitted. If you say one availability zone, you can see, for example, here you need to also mention how many subnets you want, whether you want public subnet, how many private subnet you want. Let's say I'm clicking on public subnet 1 and private subnet I'm saying 0, which means that only one subnet, and subnet will be created into only one availability zone, which is 1A. If I say I want 3 subnet, I want 2 subnet, and subnet should be created into multiple availability zone. You can see now in 1B, one subnet is additionally added. If I say 3, you see 3 subnets are added into 3 zones. The maximum 3, because only 3 availability zones are available in Mumbai. And you can see the naming convention it automatically took. So we gave a name called Book My Show. So VPC name is Book My Show -VPC, and subnet Book My Show -subnet public. So you have given public here. So when you say public, it will create only public subnet. And you can see this subnet is attached with the internet gateway. And what is routing table here? Routing table is a thing which links your subnet with the internet gateway. Okay, so internet gateway helps to uh, ensure you are able to connect to internet. Okay, so how your internet gateway is attached to the subnets with help of route table. Okay, so this is not required. So you can see now it is pretty clear. So all the three, when you click on the subnets, you can see the route, how it goes. It all the way goes and reaches your route table, and route table transfer to internet gateway. From your internet gateway routes the traffic to internet. And any incoming traffic also, it reaches internet gateway. Internet gateway transfers to route table, and route table transfer to subnet. And in your subnet, your virtual machines will be running VM. Any questions here?
Sir, here we are using IP version 4. Or
Right. IPv4.
Okay.
IPv4 is the most commonly used, not commonly, it is the one which is used across. I haven't seen anybody using IPv6 at this moment.
Clicking on no IPv6 means IPv4.
Yeah. By default, you can see here it is IPv4 cider block. Okay, so if you want IPv6, you need to click on this.
Okay. Here no IPv6 means I'm not using IPv6.
We are not using IPv6.
Okay. Okay.
Okay, so right now let's keep it only 2 availability zone for our understanding, better understanding. Now I am saying 2 public subnet. Let also say 2 private subnet. Now you can see 1 public subnet and 1 private subnet is part of my each availability zone. 1A has public and as well as private. 1B has public and as well as private. Now private subnet, I want a NAT gateway. So I can specify here, I want 1 NAT. And you can see here, NAT is not a free of cost. It's the symbol is available here to ensure, to say you that it is not free of charge. And note that there is a charge for each NAT gateway. So I'm just clicking on 1, and now you can see all my private subnets will be connected to NAT. So 1 private subnet which is in zone A and 1 private subnet which is in zone B, both are connected to NAT. If you want multiple NAT gateways, for example, you want 1 NAT per 1 availability zone, you can do that also. You can see now there are 2 NATs. One private subnet is connected with 1 NAT, another private subnet is connected with the other NAT. But generally people doesn't do that. So instead you can have 1 NAT in 1 availability zone. So if you still wanted to have a better availability. Like for example, this NAT gateway is created in 1A. You can see it is created in 1A. If in case if AP South 1A is down, this NAT gateway also will be down. So if you don't wanted that kind of problems, if you don't want to get into that kind of problems, you can go with 1 per AC, which means that now you have NAT gateways on zone A and zone B. And zone A subnets will be part of zone A NAT gateway. Zone B NAT gateways part of zone B NAT gateways. So it might be pretty confusing initially, but whenever you try to create, use this option VPC and more, so that you will get a graphical representation like this, so that it will be easy for you to understand how things are interlinked. If you are just creating only VPC and then you go to subnet console and try to create things, probably you might get confused. But when you try to do create everything into a single dashboard, like what I'm doing right now, you will be able to understand how things are interlinked, like how VPC is connected with all the subnets, and how you're splitting, how things are splitted into multiple availability zones, and how your internet gateway and NAT gateways are connected to route table, and which route table is used here. When I click on public, you can see how what is the route table of public subnet and where it is connected. It is connected to internet gateway. And if I click on this public subnet also, same thing. Okay, and if I click on private, you can see it is connected with NAT. So by this, in this way, it will be pretty clear for you to understand how things are interlinked. And again, in the real time, we will not be doing all these things. We will be creating all these things with the help of Terraform or any automation tool, what we are going to use, what it will be used in the real time. Like some companies use CloudFormation, some company use Terraform, some company use Python. So different company use different tools to create the infrastructure. So basically you will write an automation code through which all these things will be created. But before you go and do that, you should have understanding how these things are really created in the console. Now, when you have fair idea about all these things, then when you go and write a code, it will become easy for you.
So on organization perspective, we don't use console to create each services. We basically use Terraform or other type of format to build the organization platform, right?
Yeah, that's the ideal thing followed in the real time. So nobody does ClickOps in real time. So you go to any company. So that's where the people hire DevOps engineer. So our responsibility of DevOps engineer is to ensure these things are automated. So for example, any new project you're going to host in AWS, so there should be a way like things should be automatically deployed into your AWS platform or any platform for this matter. So it should be done through a code. Like tomorrow, I mean, for example, today you got a new project which need to be onboarded. You come to console and you create this networking things to host your application. Tomorrow you're getting another project where you need to freshly create all these things. Again, you come to console and doing all these things. It doesn't make sense. So you should have a code which you can reuse again and again to perform all this activity. That is what expected from any DevOps engineer.
Yeah, thank you.
Sir, I have one question.
Sure.
Sir, shall we add multiple private subnets to the single NAT gateway?
Of course, yeah, that's what we were doing here. So when you click on one AZ here, you can see I have all my private subnets are routed into same NAT. This is my private 1A, the private subnet which is located in 1A, and you can see it is routed to one NAT gateway, and my subnet 2 also routed to the same NAT gateway. So in this way, you are saving the cost where whatever you are spending for NAT. But remember, if in case something goes wrong with AP South 1A, your subnet might not be able to route to internet. I mean, your virtual machines hosted in both of the subnet might not be able to route to internet. So you need to take a call, like how critical the application is. If in case the NAT is not available and the machine is not able to connect to internet, is it a showstopper? Okay, so you need to decide that, and then you can go for it. Okay, I'll just give you a rough estimation of what would be the cost of each NAT gateway. So if you run a NAT gateway without any usage in particular region in your AWS account, I mean, for example, there is no inbound and outbound uh, happening in your NAT gateway, and it is just idle, just created and being there for an year without usage, the average cost will be around $350. Okay, because recently, like we were trying to do cleanup in our organization of all the NAT gateways, which was not used. So we did cleaned up around 12 NAT gateways, which was simply costing around $6,000 without even we were using it. We were paying $6,000 to AWS just because you're creating NAT gateway, and even without using it, you will be charged for NAT gateway. It is called as maintenance cost, right? So average cost per year for NAT gateway without usage will be around $350. If you are using it, then the cost will be different. For example, consistent inbound and outbound happening through your NAT gateway, data are getting transferred, then the charges are different. So why it is costly? Then probably you can think why NAT gateways are costly, because when you try to use NAT gateway, basically at the background, you are trying to use the AWS proxy routers. Okay, so these routers ensures that your virtual machines can connect to internet safely. But similarly, if any traffic comes from internet approaching your machine, NAT gateway should block, terminate all those connections. So NAT gateway plays a very crucial role here. So they need to deploy a dedicated routers for this particular use cases. That's the reason they are not giving this as a free of cost. But rest of all other things, like you can see VPC, subnets, route table, and internet gateway, anything you create, so they're not charging. But whereas NAT gateway, they need to maintain a dedicated hardware as a proxy to maintain to ensure your virtual machines running in your private subnets are safe and secure. Any more questions before we go and create this?
How do you find out how much it costs? Is it like a monthly based or is it like a daily based? Say if you have like you know, we
Yeah,
okay.
there is a thing called AWS pricing calculator. I should have talked about this earlier, but I forgot it. So you can just simply go and Google it, AWS pricing calculator. And this is an official calculator provided by AWS where you can forecast how much you might get charged for the resource what you're creating. Okay, so click on create estimate here. And okay, so choose by location type. For example, we are working on Mumbai region currently. So I'm selecting Mumbai. And service, I'm saying NAT gateway. So let me search for NAT. Do they have NAT available here? Probably it's part of VPC. Yeah, so here, let me just give some description. Network usage estimation. So let me just enable this NAT gateway thing and VPC. Okay, so I'm not anything. So VPN I'm not using. So all these things you can just keep it. Oh, VPN I don't want, so I'm just disabling VPN. Only NAT gateway, right? So number of NAT gateways, I'm just saying 1, and data process, for example, I'm just simply giving 1 GB per month. Okay, so assume that the data transaction to internet from my virtual machine is 1 GB approximately. Okay, so you can see the calculation here. So um, so the monthly cost would be around 40 USD, and if you calculate this for an year, that should be a way to, it will show you per year how much you would be spending. So I don't think so I can find this. Okay, so yeah, it is just
A 1 GB per month, is it like a showstopper, or is something like we can figure out?
so what, this is just a calculation. So in AWS, there you're not putting any limitation to your NAT gateway that you should transmit only 1 GB. If it goes beyond 1 GB, don't transmit. You're not doing that. Okay, so uh, so it is more on scaling approach. How much ever you transmit, it is going to allow you to do it. Okay, so it's not going to block you that, since because I mean there is no any cap as such. You can do it on your NAT gateway. Like I'm creating a NAT gateway and I'm saying 1 GB per month. So it is going to transmit 1 GB, and after that it is going to stop me. Nothing as such. You create a NAT gateway and it will transmit how much ever data you are going to transmit. Okay, and the bill will be accordingly, right? So it that's how it is. But here we are just assuming that, okay, so probably like 1 GB data I might process, and how much cost it is going to be.
Got it. Yeah.
Okay, this is more just a calculator. Okay, so assume that 10 GB and you should be able to see how much price it is going to be. So this is to understand for ourselves how much we will be charged if in case we are giving an ad gateway, and approximately, let's say for example, the virtual machine, whatever you're creating, you might know what application you're going to host. It might be a web application, or it might be a backend application, or it can be a database application. If it is a database application, eventually the transmission of data might be a bit on the higher side, so you can forecast accordingly. And once you have this information, you can just uh, you can also add more service. For example, right now I just add a NAT gateway, click on save and add. Now I'm searching for EC2, so I'm searching EC2 and click on configure. And I'm thinking I'm going to create one shared instance, number of instance one, and I'm going to select the instance type. If you don't know what it is, instance type, we will see all these things in our virtual machine when we talk about virtual machine. For example, I'm searching here uh, T3 medium. Okay, so and you can see the plans, what and all they are providing, like 3-year plan, 1-year plan, savings plan. If you want, you can procure it. And overall, you can see your monthly cost will be around $8 to run this virtual machine. Now save and view summary. You can see totally how much it will be costing for me to run this NAT gateway and as well as this virtual machine. So the NAT gateway cost will be around $41, and the virtual machine cost will be around $8. And totally to run this resource, I might be spending around $602. And remember that this is just a proactive forecast we are doing. It's not accurate. Okay, so like you forecasted it for 10 GB of data transmission, but who knows, like when you hosted your application, it might go beyond that. So there will be like plus and minus in your in this calculation. So if you're not using, like you just forecasted for 10 GB, but the actual data, whatever you transmitted is just 1 GB, then again, the bill will be lesser than of what you are expecting. So that's how it is. Right, so so monthly cost average, it is around $50, and the overall cost will be around 602. And yeah, so you can see, and you can just simply share this with your manager before you do anything. And your manager should be, or manager or management should be aware of it. Either you can download this as a CSV file, or you can share it agree and continue, and you can see you will get a link. You can just simply copy it and you can share it with your management, so that they will be aware of what will be the approximate charges we might be spending for the resource what we are going to create, and based on that you guys can take a call.
Yep, got it.
So this should be done. This like pricing calculator is pretty much helpful, and this is very essential to done. Essential to be done before you go ahead and start building your infrastructure for any new project onboarding. Okay, so which is very essential to do it, so that we don't want to go and create anything which is unnecessary, because whatever you do in cloud, so you're going to pay for it. So we need to be very cautious about what we are doing. So if you have a proper planning, so before basically the basic thing, whatever it is followed in the real time, is before you onboard any before you build any infrastructure, the first thing what people does is they do create a design, right? So you can call it as design diagram or architecture diagram, whatever it is. There are tools to do that. So tools like Draw.io or Miro. So people use different Lucid Chat. So using this, they build um, a design, and then they go for like estimating the price, estimating the cost, whatever they're going to spend for implementing that infrastructure, and then they go for implementation, right? So nobody is going to like blindly go and start building the infrastructure. So the structured way is to have a design in place and discuss about the design multiple times with people and have it get approved, they call it as sign off, right? So have it signed off with like you demo it and then get the feedback about it, and then like make the corrections whatever feedbacks you got, and then finally get a sign off and then go for implementation. So if you want me to show a basic simple design, so this is how it's going to be. Over here you can see a simple diagram which talks about like a Windows machine which will be created, uh, and what and all components we are going to use and how we are going to build it with help of Terraform and also CI/CD. Right, this is a simple design which can illustrate what's our objective, which we are going to do it. And when you before you go for implementation, when you put this forward to your management or your team, so it will be pretty easy for them to understand what are the components we are going to set up. So the tools what you can use here, as I mentioned, so to do this designing, this is very essential to do. Probably like you might not be doing it. It might be coming from a architect or from a team lead or like senior person. They will be predominantly working on doing these things, but eventually in the future, when you move towards a senior role, these sort of things are also expected from. And also it is very essential for us also to understand what are we building actually, right? So without even understanding what is the infrastructure we are going to build and what is the use case of it, and so it's pretty difficult when you go directly for implementation. So even if there is any design built by others, your senior person just go through the design and then you start working on implementation. Like, because you might be an intermediate engineer or a junior engineer, since because you guys are aspiring to become DevOps engineer, so you are not going to be a senior directly. So you will be predominantly working on implementation process. Before you go and start implementing anything, just go and if you don't know where it is, just ask your team where is the design for the infrastructure what you're building. They will guide you. Either it might be in a conference page, or it might be in a SharePoint, wherever it is. Just get the design and look through it and understand what you are trying to do. and then you start implementing it, it will be easy for you to understand. Okay, so let's go back to the VPC creation here. So I'm going to remove this NAT since because we don't want to use it. And yeah, so now your private subnets are not linked with NAT. Okay, so which is fine. So we are just seeing, I'm just showing you how to create these things. Let's go and click on create VPC and you can see everything is getting created in one stretch. And we are done with it, and go to your VPC and refresh. Should be able to see your new VPC. And you can see the CIDR range here, which is /20. And the IP address range is 10 dot, which is a private IP address range. And what should be the ranges predominantly you can use either 10 dot or 172 dot or 192 dot. And you go to subnet, you should be able to see your new subnets, fresh, and you can see these are the subnets what we created, 2 public subnet and 2 private subnet. How to differentiate between public and private? Public will have internet gateway attached. Click on public subnet and go to route table and you should see internet gateway attached there. Whereas in your private subnet, go to route table. Right now nothing is there. If in case we have selected NAT, you will be able to see NAT here. Okay, so are we good here?
Yes, sir. So if we doesn't use NAT in a private subnet, then how will we communicate with that network? Through public subnet, or how will communicate with that subnet, private subnet?
Come again with your question.
If we are not using NAT in private subnet, then how will we communicate with the machines in a private subnet?
Okay. Okay, that's a good question. So, for example, all these subnets are part of same VPC. Okay. These are all part of same VPC. Now assume that I'm creating one virtual machine in this subnet, another virtual machine in this subnet. So internally communicating between this machines wouldn't be a problem. For example, I log in into this machine. When I log in into this machine, from this machine, I will be always able to talk to this machine or communicate to this machine, or even from this machine, I will be able to log in into this machine. So there is no any intermediate things required here. The reason because all these subnets are part of same VPC. So irrespective of wherever the machine's placed, it can be in the private subnet or it can be in the public subnet. So these machines can internally talk until unless it is part of same VPC. There is no any intermediate things required here. Now the question is, if I wanted to communicate from outside, for example, from my laptop, if the machine is a public subnet, I can log in from my laptop. This is my laptop. From my laptop, I can directly log in into this virtual machine. Directly log in. I can do SSH if it is a Linux machine. If it is a Windows machine, I can do RDP, and I should be able to directly log in into this machine. And how it will work, because in between there is a thing called internet gateway. Internet gateway will take my traffic from my laptop. My laptop should be connected to internet. So traffic goes out and go in your home. You will have a router. It goes to the router, and from router it goes to the ISP, internet service provider. Internet service provider is going to redirect to a proper, for example, in this case, AWS service provider, and from AWS service provider, it reaches to your internet gateway, and from internet gateway, it reaches to your virtual machine. Okay, so this is possible because this machine is hosted in public subnet. How we are saying it is public? Because internet gateways are attached to the subnet. So any machine, whatever you're creating here, so in this case, it will be accessible over internet. Okay, so how you can ensure only legitimate people can log in? For that, you can put security group. We will talk about security group later. Okay, so that is called as firewall. So basically, to put it in a generic way. So now we have firewall. Okay, so let's not talk about it right now. So public subnet can help you to log in into the machine. Now that same is not applicable for a private machine because private machine doesn't have internet gateway. And we also have NAT. NAT will not allow incoming traffic. Then how we can log in into the private machine? So how you can log in? In that case, you need to first log in into this public machine. From that machine, you can log in into the private machine. So basically, this is what in real time they call it as jump server, or they call it as bastion machine. Okay, so you might have heard people talking as jump server or bastion machine. What exactly they mean by is any people who wanted to log in into the private machine, first they will land into the public machine. From there, they can switch to the other machine. How this is possible? Because this private machine is running in the same VPC. Did I answer your question?
Yes, sir.
Any more questions? I think, I mean, this is the hands-on thing what I wanted to talk about today. So everybody can go back and try to see, create your own VPC subnet in any region. Okay, for this matter, you can take any region. And you can start trying to replicate the same what we did here and try to see if you're able to create the VPC and subnets. And when you click on the subnet, you should be able to see the subnet is created in small chunks. Okay, so you can see here it is created as /24 and around 251 IP address is available as part of it. And it would have been equally splitted into small sizes. Okay, so that is done by AWS itself. So if you wanted to customize, you can do still click on create subnet and select your VPC, which VPC you want to create a subnet, and give your subnet name and give the CIDR range, whatever you want. And you can also create a subnet. We didn't follow this approach. We directly created from a VPC console itself. So it was pretty easy for us. But in future, you wanted to add more subnet, you can't do the same again. You need to come here and click on create subnet, and you need to select the VPC under which you want to create subnet. And then you need to give a subnet name, which availability zone. For example, I want to put it in 1C, and then I need to give the CIDR range here, like 10.0.0.0 slash, like let's say 26. Okay, so I'll get 64 IP address, and so totally we had around 4,000 IP address, out of which we already created 4 subnets, small subnets with 256 IP address. We are creating additional one which will have 64 IP address. So until unless the 4,000 IP address is getting completed, you can keep on creating subnets. When the time when VPC is out of IP address, like you created subnets to the maximum, then it's not possible to expand the VPC. Okay, so there is no any way to go and expand the VPC for more IPs. You need to go with new VPC only. Okay, that's why when you create a VPC, you need to understand what is the use case, and also you need to think futuristic, like in future how many more machines things might get created. Based on that, you need to plan your VPC, because there is no possibility of expansion here.
Even using Terraform?
Through anything.
Okay.
Terraform is just going to do what AWS accepts, right? So Terraform cannot do the thing what AWS doesn't accept.
Correct. And then if it does exceed, then we have to create new VPC and then connect both together.
No, the new VPC is going to be individual.
Let's see.
But if in case you wanted the workloads, for example, you have certain machines running here and you are creating a new VPC where you're going to host new virtual machine in that VPC. And if these two things need to communicate each other, if it is a public subnet through internet, it will communicate. What if the machines in the private subnet wanted to talk? That's where they have a concept called VPC peering. I think it is peering connections through which you can link two VPCs. Like you have VPC book my show, let's say this is VPC 1, and you're creating one more VPC book my show VPC 2. Now the workloads between these two VPCs need to talk without internet. Then you can use this peering connection option where you can link these two VPCs. But without this, both are individual. Okay, so if you wanted to ensure the things are communicating internally each other, then you need to additionally do this. And you can do peering to different region also. Like for example, this VPC is in Mumbai region and you have another VPC which is created in US East 1. Still it is possible to do peering. And also you can do peering to different AWS account, VPC which is running in different AWS account also. Okay, it doesn't mean VPC supports in only one single region or one single account. So it is possible with multi-account or multi-region also.
Then what is the role for NAT gateway on this peering connection?
NAT gateway doesn't play any role here. So NAT gateways predominantly comes in providing the internet access to your workloads in private subnet. You created a private subnet. Under the private subnet, you created a virtual machine. What if a virtual machine wanted to communicate to internet in a safer way? Then the NAT gateway comes into picture, right? So whereas peering is about linking two VPCs together.
Okay, thank you.
So it might be initially quite confusing. So I would say go and try to do hands-on and try to create things and see how it works for you. While creating, you might get a lot of doubts, like what is the use case of each and everything. So come back with your questions. We can discuss about it and get it clarified, because all these things are very essential to understand, and these are the basics. Okay, so how much ever strong you are in basics, it is pretty easy to build the knowledge upon, right? So if you are not understanding the basics itself, how much ever you learn the things like the advanced things what cloud provides, still you will not feel confident. So focus on this and understand each and every options whatever they are providing in this networking concept. Then it will be easy for you to build the knowledge around it. And there will be a lot of questions asked around this concepts in interviews, because this is again a work of DevOps engineer. So in many companies, you will be responsible to set up the networking for any project, whatever you're going to onboard. So it will be part of our role, right? So either you join as SRE engineer or DevOps engineer. So this will be part of our work. So in interviews, there will be a lot of focus on this, right? So NAT gateways, internet gateways, VPC peering, and routing table, private subnet, public subnet. So they will try to put a lot of questions around this. So you should be very clear by yourself so that you can answer in a better way.
I've been asked one question on this. Okay. They asked me how can one service can communicate with another service?
I think we discussed about it right now before this. If you remember, where you have different subnets, and when they call it as service is nothing but a application which will be running on a virtual machine, or let's say it is a container. I mean, let's not talk about whether it is a container or a virtual machine. Okay, so service is nothing but an application which will be hosted on a virtual machine. And one virtual machine is running in this subnet, and other virtual machine is running in this subnet. If it is part of same VPC, it can easily communicate internally, right? So this is what we were talking about. If it is part of different VPC, right? So here you have two VPC, like service A is running in this VPC and service B is running in this VPC. Then the service can communicate each other through internet. But if you don't want service to be communicating over internet, then peering is something which you can do between the VPCs.
Yeah. I mean, I didn't give answer like that, but kind of say resources, the resources we can communicate with each other services.
Okay. So the question is more on the cloud front, right?
Yeah.
Okay. Okay, so when you attend interviews, if you get such kind of questions where like post after interview, you still didn't understand, or you're kind of paranoid about that question where you try to find it, but you're not able to find, you want some explanation, just post the question in WhatsApp to me, so I can respond with answer, or we can discuss over the call offline as well.
Yeah. Have you shared your number in the group by any chance?
It is there in the GitHub repo.
Okay.
And Vijay, that GitHub repo, it's not updated.
Okay, so let me do it right now. Yeah, there are some files not updated. Okay, so you should be able to see the files now. Yeah, thank you. Okay, I think we are done for today, so feel free to drop off.
Okay.
Okay, thank you. Bye bye.
Thank you, sir.